Hello everyone, my name is Chris. I'm a developer relations at Algorand. And this is going to be a quick 30-minute talk on how you can get started building on the Algorand blockchain. Now when you're a developer just exploring different chains, the first thing you want to find out is how do I get started? Right? What are the tools do I need? What are the languages that I need to learn? So in this talk, I'm going to cover everything that you need to know to get started so that you can deploy your first smart contract on the Algorand blockchain. Now, as a developer, when you come to Algorand, the first thing that you need to do is install AlgoKit. Now, AlgoKit is an all-in-one developer tool for Algorand, and it has all these features. Like it has a CLI, it has a high-level smart contract language, utility frameworks, and more on that helps you to get your project from zero to hero in the most streamlined way. So I'm just going to dive right in and show you a quick demo of AlgoKit and how you can start creating an Algorand project and deploy your first contract. All right, I'm going to come over to here to my terminal. Let's make that a bit bigger for you. First thing you want to do is install AlgoKit. So you want to run pipx install AlgoKit. Now, I'm not going to install it because I already have it installed, but this simple command is going to install AlgoKit globally on your computer so you can access it from anywhere. Now, after installing AlgoKit, you want to run AlgoKit init. And this is going to start an interactive session that's going to ask you a series of questions about what kind of project you're trying to build. So first question, hey, tell me more about your project. Are you trying to build a smart contract project? So you might have an existing front end that you just want to plug in a smart contract. You choose the smart contract template. You don't want to do anything with smart contract. You just want to interact with the chains, send transactions. You can use the front-end template. And if you want both of them, you can choose the full-stack template. For this demo, let's go through initializing a smart contract template. Then it's going to ask you, hey, what language do you want to write your smart contract in? Now, in the Ethereum world, you have Solidity, which is a TypeScript-like language for smart contracts, Viper, which is a Python-like smart contract language. And it's kind of similar over at Algorand. You can write your Algorand smart contract in both Python and TypeScript. The only difference is that at Algorand, it's not a Python-like or TypeScript-like language. It's actual Python and TypeScript. So all of the code that you write when you're writing your smart contract will be 100% native Python and native TypeScript. Yeah, that's right. And I think this is pretty cool, right? As a developer, when you're trying to learn how to build stuff, a part of that equation is learning a new language, right? Or learning a new smart contract language. And that's tough. Like, we don't have time for that, right? So you just want to be building in a language that you're already familiar with. And Python and TypeScript are the top two most popular programming languages out there. For this demo, let's choose the Python language. Then it's going to ask you to name the project. Let's name it ETHDenver 2025. Then it's going to start rendering the project. Then it's going to continue asking some questions. Seems like we're having some Wi-Fi issues. Okay, cool. It's going to ask you to name your smart contract. I'll just leave it as hello world for now. You can change it later, so don't worry about it. Then it's going to ask you to choose a preset. Now, the AlgoKit templates are quite flexible. So if you are just, have a quick idea you just want to test and play around with, you can choose a starter template. It's very lightweight, doesn't have a lot of configurations. But if you are using this project to build a production-ready application, you want to choose a production template. It has all the CI/CD pipelines and integration with Vercel and Netlify so they can directly deploy your app to one of these providers. So it has all those nice features just built in for you. So let's choose a production template. Then it's going to ask you what language you want to use for contract deployment code. Now, after you write your smart contract, you need to deploy it and you need to call it, right, in your application, and you need to write code for that. So it's asking you what language do you want to do that in. And we provide two utility libraries called AlgoKit utils, both in Python and TypeScript. So if you want to write your contract interaction code on your Python backend server, you can choose the utils Python library. Or if you just want to do it all on the front end, you can choose the TypeScript library. To keep it all Python, let's choose Python. Then it's going to ask you to run AlgoKit project bootstrap. Now, I'm going to keep that running because it's going to take some time. That is an AlgoKit CLI command that's going to automatically detect all of the dependencies your project needs, and it's going to install them for you. So this means no more manual installing dependencies, figuring out version conflicts. AlgoKit handles it all for you, so you don't have to spend time setting up your development environment. You just get right to building. Cool, so AlgoKit has installed all of my dependencies, and it's gonna ask you, hey, you wanna make it into a Git repository? Obviously, we say yes to that. Now, after that, it's going to open up VS Code, and it's gonna open that created project. Now, this happens because I have my VS Code as my default editor. If you don't like VS Code, you want using a different editor, just don't worry, you'll just cd into that project and open it in your favorite editor. Cool. All right. So this is the created project. So let's take a look at what it looks like. Right now, AlgoKit has automatically created this project in workspace mode. Now, for those of you who don't know what workspace mode is, it's basically a nice VS Code feature that lets you handle a mono repo with multiple projects inside of it in one single editor. So the way AlgoKit creates this project is that it creates a workspace, an AlgoKit workspace. And inside of AlgoKit workspace, you can have multiple projects. So multiple smart contracts, a front-end project. You can put it all inside of one AlgoKit workspace, and you can work with it inside of one editor, inside of workspace mode. So if I were to go to my terminal and run AlgoKit init again in the root terminal, like that, that's going to, after I go through it, it's going to create another project inside of that workspace. But let's not do that right now. Okay. Now let's take a deep dive of this created smart contract project. Now this looks very scary. I know, there's a lot of files, but you really don't have to worry about all these configuration files here as a beginner. You can go in and change some stuff when you know what you're doing. But for now, all you need to worry about are the smart contracts folder and the test folder. The smart contracts folder gives you the default hello world smart contract in the contract.py file. So that right there is the hello world contract written in Algorand Python that comes with the template. Now, if you're a Python developer, that code should look very familiar to you. It's just a simple Python class named hello world. It's inheriting this arc4 contract class, and it has one method named hello that returns hello with the name argument. So like I said, when you're writing your smart contract in Algorand Python, you're just writing Python code. And we have a compiler that understands this and compile it down to a low-level TL code that the AVM understands. Cool, so now let's try building and compiling this smart contract, because like I said, the AVM doesn't understand Algorand Python. This is just a nice tool for us, right? It makes our life easy as a developer, but the AVM hates it. You know, AVM only likes TL. So we need to compile it. To do that, open up your terminal, go inside of the terminal of the project that you're working in, remember it's in workspace mode, and then run AlgoKit project run build. Now this simple command is going to go through all of the smart contracts inside of the smart contracts folder. So if I had multiple contracts inside of this smart contracts folder, this build command is going to build and compile all of the smart contracts for you. So that went through and has created this artifacts folder right here. Inside of this artifacts folder, we have those two TL files. So this is the TL code of the smart contract that we just saw. Like I said, it's really hard to understand, but AVM likes it. And then we have this arc56.json file. Now, this is an ABI spec of our smart contract. Now, what I mean by that is it's basically an instruction for your smart contract. It has all of the details about your smart contract that you will have to know about. So AlgoKit uses this ABI to automatically generate a hello world client.py file. Now this is an application client class that later you'll be using as a gateway to deploy and interact with your smart contract. So let's take a look at how you use this application client. Inside the hello world folder, we have this file called deploy_config.py. Now this comes with the template. And what this is doing is importing in AlgoKit utils. Remember the utility Python framework that I talked about? It's importing that. It's also importing this hello world factory class from the hello world client, the file that we just took a look at. We're using that factory to create a factory instance, and we're using that factory instance to deploy our hello world smart contract. Then it gives you a return value of an instance of an app client that is synced to that deployed Hello World contract. So now we use this app client instance to call the hello method. So this one line of code right here is using the app client instance. It's sending a transaction, it's calling the hello method, and it's passing in the argument name, which is assigned to world. And we're going to print those out. So let's run this deploy script. Open up your terminal again, run AlgoKit project deploy localnet. Now, this command is going to run that deploy script and deploy our contract to an Algorand local blockchain. A local blockchain is a private blockchain that only runs on my computer, so nobody has access to it. It's not public. You don't need to ask for test tokens to build on the test network. You can just do it right in your local network, super fast, super secure. But for me to do that, I need to have my local blockchain running on my computer. So to do that, again, we use AlgoKit, and we run AlgoKit localnet start. And this command is going to launch a local blockchain running on my computer that I can sync with and interact with. Right now, I have it running in my Docker container over here, and it will turn on when you run this command. Okay, so let's deploy it to our localnet. AlgoKit project deploy localnet. Now this command, what it's doing is, again, it's looking at the smart contracts folder and is looking for all of the deploy config.py files inside of this folder, and it's going to run all of those deploy scripts. So if you have multiple smart contracts, it will deploy all of those smart contracts. If you just want to deploy one of those contracts, you can add a flag there and say, hey, I only want to deploy this contract. Cool, let's look at the return value. Here it's saying, hey, we're deploying the app hello world, and we got the return value hello world. So if I go back to my deploy script and change this to hello ETHDenver 2025, save it, run that deploy script again, now we get the return value hello ETHDenver 2025. So, yeah, a working demo, guys. That's crazy. I expected this to go sideways, but it's going good so far. Okay, cool. So that's a proof that we are interacting with a deployed smart contract on our local blockchain. Now, I want to give you guys another tool that you can use when you're developing your application, and that's LoRa the Explorer. Now, yes, you get the joke. Cool. Now we go back to our terminal and we run AlgoKit Explore, and that's going to open up LoRa the Explorer in your browser. Now, what is LoRa? LoRa is a block explorer. So it actually connects to all of your networks, like mainnet, testnet, betanet, and you can use it just as a block explorer to look at what happened inside of one block, what kind of transactions, like transaction details. You can look up assets, applications, all of it. You can do it all through LoRa. But what's amazing about LoRa is that it's a dev tool as well. It can configure and connect to your local blockchain running on your computer. And when you ran AlgoKit Explore, it automatically configured LoRa to localnet, as you can see over here. So let's try using LoRa now to deploy that same Hello World smart contract to our local blockchain and call the hello method. First, click Connect Wallet, and here I'm going to click Connect KMD, and that's going to connect me to a wallet that my local blockchain provides me by default. So it's a test account that you can play around with. You can also choose Loot Wallet. It's an amazing wallet that's perfect for developers. We have a developer of Loot Wallet right here, Andrew. And Loot's amazing because it's a perfect tool for a developer. It connects with localnet, and most developers love it. So you can choose Loot if you have a Loot wallet. But I'm just going to use KMD for now. Now let's go to App Lab, and this is where all the magic happens. You can use this to deploy your smart contract. So let's click Create. Click Deploy New, and here it says, select an ARC32 or ARC56 JSON app spec file. Now remember, we took a look at the ARC56 JSON artifact that was automatically created when we build our smart contract, right? And that's the ABI spec. So LoRa wants me to provide that. So I'm gonna open it up. Oh no, I'm gonna have to find my project here. Okay, going in, project, ETHDenver 2025, smart contract, artifacts, and here we go. Here's the ARC450. Oh, wow, that's blurry very blurry, but that's the art56.json file, just trust me. So I'm gonna open that. I'm gonna click next, next again, call, and this is a page where it's building an application create transaction. Now when I say application, we mean smart contracts. We use them interchangeably. So we're gonna add that app create transaction to our transaction group, and we're gonna click deploy. And just like that, we were able to deploy that Hello World smart contract that we looked at before to our local blockchain. Now, if I click into the app ID over here, it takes me to an application page on LoRa. And on this page, it gives you all of the details about your application, like the ID, the name, who the creator is, and we have this thing called account here. If you've built on Ethereum, you know that all smart contracts are accounts, right? So they have an account address as a unique identifier. Well, it's kind of different on Algorand. On Algorand, Algorand smart contracts are just programs with a unique identifier of a number. And so they're just programs that runs business logic. So if you want your Algorand smart contract to handle any type of wallet-related operations like receive tokens or send transactions, you have to do it through an associated app account to your smart contract. So all Algorand smart contracts has an associated account. Cool. Now let's take a look at this ABI methods section. And you can see the hello method over there. I can open that up, and it gives you all the details about this method, like what kind of argument it takes in and what the return type is. To call this hello method, I come over here, click on call, and again, it takes me to the build transaction page, and I'm going to now pass in an argument. This time, let's say hello to Chris, because that's my name. I'm gonna add that transaction, gonna send it, and there you go. We basically did the same thing, but just through a visual interface, we got the return value, hello, Chris. And LoRa is truly amazing. You guys really have to check this out. Like, we can go inside of the transaction ID that we just sent and take a look at all the information about that transaction. Like where, and what block this transaction happened, the fee, who the sender is. It even gives you a visual representation of that transaction. So now later on, when you're building more complex applications and you have a bunch of inner transactions that your smart contract is sending, and they're all happening atomically at the same time, because that's a feature in Algorand, you will see a visual graph of all these transactions happening, and you can decipher what's really going on in a visual way. So there you go. I just went through the whole workflow that you will be doing as an Algorand developer. You can use AlgoKit to bootstrap a project, you use it to write your smart contract, build it, test it. Oh, I forgot about the test part. Let me go back to the editor. Okay, coming back here, I forgot to talk about this test folder. When you write smart contracts, obviously you want to test it. Yeah, it's very important if you didn't know. Usually smart contracts handle some form of value, so you want to ensure that your smart contract is tight, right? No security vulnerability. So to write your test on your smart contract, you open up the test folder, and the template gives you a default test called hello world client test.py. And this is a test script. Oh, I'm in the wrong editor. Here we go. Okay. There we go. Okay, yeah. The template gives you a default test script. And it's really doing the same thing. It's importing in AlgoKit utils, it's importing in the factory, and it's going to have some test cases. But what's really nice here is that if you're a Python programmer, you're probably used to this testing framework called Pytest. Now, this is one of the most popular testing framework on Python, and if you write Python programs, you usually test your program using Pytest. So what's amazing is that you can test your Algorand smart contract with just a Pytest, like with Pytest. So you're not learning another testing framework to test your smart contract. You're using the same tool as a normal developer would to test your smart contract. And this is just another feature that AlgoKit brings to you. So this test script is creating a test account, is creating the app client instance, and is testing the hello method. We're calling it, and we're asserting that the return value is hello world. So to run this test file, we do it through AlgoKit again. So we do AlgoKit project run test, and that command is going to look for all the tests that are inside of this test folder and run all of them all together. So you can see it ran these tests, and it says It all passed, and we got that green check mark that we always strive for. So I know I zoomed through a lot of stuff, but that really is all there is when you're building an Algorand project. There we go. Back to my slide. Yeah, so you can kind of see what you'll be going through as a developer, right? That's the workflow. You edit your smart contract, you edit your test file, and you go back and forth. You test it on your local net, and later on, when you're ready, you launch it to testnet and mainnet, and you're ready to go. And you can go through what I exactly did right there by scanning this QR code, because this is going to take you to our Getting Started guide. And that Getting Started guide is going to teach you how to install AlgoKit all the way to how to deploy your Hello World smart contract using AlgoKit and LoRa. So hopefully this talk has kind of given you a sense of where you can get started so that you don't have to spend hours and hours trying to figure out where to start. I wanted to remove that headache for you so that you could just get right to building and ship products. Thank you. Yeah, you do.
What's the rough difference between using AlgoKit versus Pytest?
Ooh. So the question was, what's the difference between using AlgoKit and Pytest? Now, to give you some context, Pytest was our old smart contract language that we used on Algorand, and it was a Python-like syntax smart contract language. Well, I would say the advantage is that when you write your smart contract with the new language, like Algorand Python and Algorand TypeScript, it's highly integrated with the entire AlgoKit toolset. So you can write test more easily, you can deploy it more easily, and also the contract itself has better, more elegant syntax, because now you don't have to worry about Python expressions and stuff like that. You just write Python code and it works. Right? So I think there's a lot of benefits, and more features are going to be added to AlgoKit, so your experience is only going to get better. If you choose to just use Pytest, you're free to do so, but highly encourage you to try migrate over to AlgoKit, because the experience is just continuously going to get better, and you're going to be left out of that if you use Pytest.
Effectively a wrapper around Pytest?
No.
It's not touching at all?
It's not touching at all. It's completely new. Pytest is completely separate. Right. We built a compiler called Puya, and this Puya compiler is magic. Yes. And what's amazing is right now we support we support Python and TypeScript as a high-level language, and the Puya compiler understands both of those languages and bring it to Teal. But later on, the Puya compiler is so versatile that you can add other high-level languages. So if you're a Go programmer, you can add a Go language. If you want to bring Solidity to Algorand, you can add Solidity. As long as the compiler understands it and bring it down to Teal, whatever language you write, you can make that happen. So, yeah. Any other questions? Cool. Well, our developer relations team, Brian, myself, and Gabe, we're going to be around. If you want to get through this Getting Started guide while you're here, you can do it in like 10 minutes. We'll help you get through and help you get started. All right. Thank you so much.